All right, folks, this section of notes is going to be about area. Okay, now area is the space inside of a shape. So hopefully you can see this okay. There's some squares marked off in here, some graph paper squares. So area is the space inside, and we measure that in square units. Okay, so to find area, we want to know how many squares there are inside of a shape. Well, if you can see them and count them all, there's 24 square units inside that shape. 24 square units. Again, as many of you know, that's also 6 times 4. So area is the space inside of a shape, and we measure that by partitioning it off into squares and counting the squares. Now, luckily, we have formulas for that most of the time, and we will use them, um, especially for right now. But again, just keep in mind area is the space inside of a shape, and perimeter is the length around the shape, the distance around the shape. So perimeter is like the fence, the area would be like the size of the field encompassed or enclosed by that fence. Okay, so as you all know, and as you saw up here, the area of a rectangle is length times width. And this is important. We're going to keep coming back to that here in the next few minutes when we look at some other area formulas for parallelograms, trapezoids, and triangles. So area of a rectangle is length times width. Here's one right here. Let's say we got 4 centimeters on that side, 5 centimeters on that side. Well, the area is just 5 times 4, or 20. And you could write the units either way. The units are important. I will expect you to put them on every answer on your tests and quizzes. So you could say square centimeters like this, SQCM, and abbreviate everything. Or you could use a little exponent of a 2. We often call the second power squared. So 20 centimeters squared, or 20 square centimeters. This is probably how I will write my answer most of the time. So that's cm with an exponent or a little 2 up above it there. Okay, let's look at some of our other shapes. So here we've got a parallelogram. Okay, so how do we find the area of a parallelogram? Well, let me kind of show you how we do that. Let's say I'm going to take this parallelogram and I'm going to cut this triangle off right here. And I'm going to move it over to this side here and attach it right there. Okay, so what I've done is cut out this triangle and stick it on the other side. I didn't change any of the area, I just changed the shape a little bit. And you'll notice when I do that, look, we've got a rectangle. Okay, so this parallelogram I turned into this rectangle. Now you know how to find the area of a rectangle. I just changed the words a tiny bit. Instead of length and width, I'm going to use base times height. So the area of a parallelogram is base times height. So it's very easy to transform a parallelogram into a rectangle, and by doing that we know that the formula is the same thing, base times height. The thing you have to be very careful of though is you always want to use this 90-degree height. You don't want to use one of the sides over here. You want to use the perpendicular or 90-degree height when you find the area of a parallelogram, and I'll show you what that looks like here in just a second. Okay, so area of parallelogram is basically the same as a rectangle, base times height. Just make sure you use the right numbers when you do that. Okay, so here's an example of one right here. Okay, the base is 3.5 and the height, this 90-degree height, is 5. Let's say, for example, that the problem also had this number over here, 8.2 centimeters written on that side. We are not going to use that side. We would use that to find the perimeter, but we are not going to use that to find the area because it doesn't make a right angle with the base. You always want to use the right angle height when you find the area of a parallelogram. Okay, so area would be the base, 3.5, times the height, 5. Okay, I'm going to do this without a calculator. So 3.5 times 5, let's see, 5 times 5, 20, oops, darn it, 25, 2 up here, 5 times 3 is 15 plus 2, so 17, I'm sorry, 175. I've got one number after the decimal there, so I need one decimal place in my answer, so 17.5. So area equals 17.5 square centimeters. Again, I'm going to write it like that with the exponent most of the time. Okay, base times the 90-degree perpendicular height. Multiply them together. Okay, now let's think about triangles for a minute. Now, again, if I can go back to something we know, we can figure out the area formula for a triangle. So we know what the area formula for a parallelogram is. Now, what if I can somehow turn this into a parallelogram? Well, I can. I can take this triangle and attach it to itself over here. Just like this. Okay? So I just took this triangle, I swung it around and stuck it on this side over here. So you'll notice that our original triangle, this blue one, is half the size of this parallelogram that I just created. So the area of the triangle is half the area of the parallelogram, which is base times height. Okay? So that's where it comes from. It's half the area of a parallelogram that you could make by flipping the triangle over and sticking it on that side over there and turning it into a parallelogram. Okay, that's where the formula comes from. Triangle area formula is 1/2 base times height. Okay, you don't need to do this when you're doing the problems, you just need to use the formula. Okay, I also like to do the formula this way, base times height divided by 2. So I'll write that here, base times height, and then you divide that by 2. That way you don't have to worry about fractions so much. I usually do it this way most of the time. Base times height divided by 2. Again, just like with the parallelogram, you got to make sure and use the 90-degree or perpendicular height. Okay, so here's one here. Let's figure out the area. So the area is, I'm going to do it this way. I'm going to do 5.9 times 3.2, and then I'm going to divide that answer by 2. So with decimals, this gets to be a little tedious, but I would like you to practice these without a calculator this week, just so you can keep working on your decimal multiplication. Okay, so 5.9 times 3.2, I will do them without a calculator also. 2 times 9, 18, 1 up here, 2 times 5, 10, plus 1, 11, 0 down here, 3 times 9 is 27, 2 up there, 3 times 5 is 15, plus 2, so 17, 8, 8, 8, 1. Okay, now we got to figure out how many decimal places are in the answer. Well, I got one number after the decimal here, another one here, so that means there's 2 decimal places in the answer. Now remember, you're not done. We got base times height, but now I need to divide that by 2. So I'm going to go 2 into 18.88. And this won't be so bad. They're mostly even numbers. Okay, so 2 doesn't go into 1. 2 goes into 18 9 times. 2 times 9 is 18. 0, drop down. Oh, before I drop down the 8, I'm going to make sure and put my decimal up here in my answer. Just bring it straight up. Drop down the 8. 2 goes into 8 4 times. So 4 times 2 is 8, subtract 0, drop down this 8, and 2 goes into 8 another 4 times. And I'll just finish that off there. So I'm done. Okay, so there's your answer. Base times height, divide that by 2. So the area equals 9.44, and again we need to use square units. We started with feet, so we've got feet squared. Okay, so area of a triangle, base times height divided by 2, or 1/2 base times height. Either way is fine. Okay, there's one more shape that we're going to look at tonight, and that is trapezoids. Okay, so I've been trying to show you where these area formulas come from. It's nice to know them, but it's also nice to know where they come from. So here's a trapezoid. A trapezoid has one pair of parallel sides. Okay, again, if I can somehow use what I already know, I can figure out the area formula for this one. And once again, we're going to go back to our area formula for a parallelogram, and I'll show you how in just a second. So like the triangle, I'm going to take this trapezoid and spin it around and attach it over here. Okay, so let me do that. Okay? I just did, okay? So this is the same trapezoid, same shape, and look, I just made a parallelogram. So the area of my trapezoid is going to be half of whatever the area of this parallelogram is. So we don't quite know everything about this parallelogram, sorry. We know that the height is here, but how long is this bottom side? And at the top, they're both the same length. How long are they? Well, this length right here, this is base 1, and this right here, this is base number 2. We call the parallel sides of a trapezoid bases. So the bottom one I call base 1, the top one I call base number 2. So this length of this parallelogram I just made is base 1 plus base 2. So the area of my trapezoid is going to be 1/2 of the area of this parallelogram I just made. So area equals 1/2 of base 1 plus base number 2. That's this whole bottom side times the height. And there's the formula for a trapezoid. You take the two parallel sides, add them up, multiply that by 1/2, and multiply that by the height. Again, I like to do this a little bit differently. I'm going to sort of just rearrange this a little bit like this. So area equals, I'm going to go base number 1 plus base number 2, and I'm going to divide that by 2. I'm just moving this 2 on the bottom, and then I'm going to multiply that to the height. Okay, so add the bases, divide that by 2, multiply that to the height. And it's like finding the average of the bases is another way to think about this. So again, I'm just trying to show you where these formulas come from, and they come from what we know about the way to find the area of a parallelogram. Okay, so this is what I'm going to use to find the area of this trapezoid. First thing I need to do is add the two bases together. Okay, so 10.7 plus 6.9. Okay, so that is 7 plus 9, 16, decimal down there, a 7 and a 1. Okay, so again, let me write it out here. So I'm going to go base 1 plus base number 2, which I just worked out. I'm going to divide that by 2, and then I'm going to times that by the height. Okay? Add the bases. I just did that, and I'm going to divide that by 2. So 2 into 17.6. Okay, 2 goes into 17 8 times. 16 here, subtract. Bring the decimal up. I got a 1. Drop down the 6. 2 goes into 16 8 times. Okay, so add the bases, which are the parallel sides. Divide that by 2. And then multiply that to the height. Again, we're going to do these without a calculator this time. So 8.8, and the height is 4.2. Just got to do a little multiplication here. Okay, 2 times 8, 16. 1 up here, another 16, 17. When I add 1, 0. 4 times 8 is 32. 4 times 8 is 32 again. Plus 3 is 35. 6, 9, 6, and a 3 when I add those up. And again, one number after the decimal here, another number after the decimal there, so that's 1, 2 places in my answer. And there we go. So the area, I'll write it out over here, equals 36.96, and it's going to be millimeters squared, or square millimeters. And there's the answer. Okay, let me just walk through this one more time. Add the parallel sides, add the two bases, step 1. Okay? Step 1 is here. Step 2 is right here where we divide by 2 our answer from step 1. So you add the bases, divide that by 2, and then step 3 is to multiply this answer by the height, which was 4.2. Again, we're always using the 90-degree height when we do that. Okay, so you've got a few worksheets to do. You've got parallelograms, triangles and trapezoids, and I really hope this helps. And if you have any questions at all, please let me know. Thank you.